Okay, good morning, everyone. So today we're going to be looking at the binomial theorem and Pascal's triangle. Okay, so first off, what is binomial theorem? So binomial theorem, we're talking about the pattern we find when we have binomials, or like things that look like this, n plus 3, or 3n plus 2. These are just examples of binomials. They have two terms, right? So that's 1, that's 2, 1, 2. And if you multiply these binomials by itself a number of times, so if you're taking the exponents of them, it's going to have a pattern that looks like this. Now, we've looked at those patterns, on Friday. There were 3 types of them. But now we're going to see how these patterns were developed. Okay. So in order to help us understand binomial theorem, we're going to look at Pascal. So Blaise Pascal, he's the guy who developed this the Pascal triangle, and he also developed an early form of a calculator. And what we mean, and when we're looking at his triangle, this is the pattern that the binomial coefficients will follow. Okay. So usually in the triangle, you have like ones on the side, but the middle, it's made of the sum of the two of the numbers directly above it. So I'm going to keep 1 on the ends, and in the middle, I'm going to add the 2 ones over here. So that's 2. And then over here, for my 4th row, right, I'm going to keep the ones at the end, but I'm adding the 2 numbers that are above it. So 1 plus 3, that gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. So if we're going to combine this Pascal's triangle with our binomial theorem, or binomial expansion, it'll follow this pattern right over here. So if we look closely, we notice that over here the coefficients match the coefficients that we find in our end result, our end polynomial, when they get multiplied to each other. And notice how everything here, it's going to be plus y, plus y, plus y. And if we look closely at the powers, right, whatever is the first term, we're going to start off with the 2 over here, because we're getting the 2 from this exponent down here, and we go down to 1. If you don't see an exponent over the variable, automatically assume that it's a 1. Now, so when it goes from 2, 1, it's decreasing. And then from our second term, y, right when x goes down by 1, it's going to start. So this is going to be 1, and then the exponent is going to 2. All right. So let's say I was doing something with our 6th term, right? Just to show you how this all works out. So I'm going to keep 1s at the ends, and then I'm going to have the sum of these guys. So I'm going to have a 6, a 15, a 20. So I'm doing 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 1 plus 5 is 6. So these would be the terms for my 6 entry. And if I was doing something like my first term plus my second term to the 6th power, it's going to look like this. I'm going to start with my x's first. First, the exponents of my x's are going to go down. So x6, x5, x4, x3, x2, x, and then there's like a constant. Now let's look over here. If I go past x1, my x's are going to go away. So now let's go put in our y values. So I'm going to leave x to the 6th power alone, and I'm going to start over here. I'm going to start in the opposite way, increasing. So it's going to be y to the 1st power, y to the 2nd power, y to the 3rd power, y to the 4th power, plus 1, 2, 3, 4, y to the 5th power, plus y to the 6th power. So you see how your exponents is, for the first term, is decreasing. 6, 5, 4, 3, 2, 1. And then for your second term, it's increasing. So it's 1, 2, 3, 4, 5, 6, right? And then I'm just going to input all of these coefficients. So it's 1, it's a 6, there's a 15, there's a 20, there's another 15, there's a 6, and then there's a 1, right? So that's how Pascal's Pascal's triangle works with binomial expansion. It's basically telling you the format, your end result, when you multiply this